Okay, this is my Embedded Systems homework number 8 project, problem number 3. For my requirements, I'm going to have my input set to RB0 and my output to the display. My relationship is going to be, I'm going to generate a pseudo-random, and I say pseudo-random because it's dependent upon the press of my finger, as well as a timer 2 interrupt set to every 1 millisecond. We're going to generate a pseudo-random number between 1 and 10 when RB0 is pressed, display that number on the LCD, and send the number to the serial port. Here's the flow chart here. Okay, so for the main routine, we start, initialize the timer 2 to 1 millisecond. Check to see if RB0 is pressed. If not, we keep checking. If it is pressed, we generate the number, we display that number, and we output the number to the serial port and start over again. For my timer 2 interrupt, we'll start it every 1 millisecond, we'll increment a variable named time, and we'll exit. Okay, so the math behind the timer interrupt here is the processor gives us 10 million clocks per second, and we want our interrupt to be every 1 millisecond, so that's going to be every 10,000 clocks. So we set B to 250, C to 4, and A to 10. It means PR2 is going to be 249, which is B. 249 plus 1 is 250. And then our T2 con will have 0, ignore that bit. 1001 is A, that's 9 for 10. 1 for the timer bit. And then 01 for C is equal to 4. So this is our project over here. We've got the LCD displaying the die, RB0 here, and there's our pseudo-random numbers. As we are pressing this, that number gets sent through the serial port. So I ran a trial here where I did 50 rolls, uploaded the 50 rolls into MATLAB into a matrix, tabulated the matrix, and I got this for the frequency of the numbers rolled, and I took those values. We made a chi-squared table. So here are our values. Here are our expected results out of 50 rolls. Here are our actual results out of 50 rolls. And these are our chi-squared values. Total chi-square value is, chi-squared value is 4.8 with 9 degrees of freedom. Gives us a p-value of 0.15, courtesy of StatTrek. And so that means that there is a 15% chance that this die is loaded. And that is my homework number 8 project.